Good morning, good evening, good afternoon, depending on where you're joining us. Welcome to Immersed. My name is Brian Anthony, and I'll just get us kicking off this afternoon with our new seminar series. Immersed is a seminar series designed to accelerate and enhance and enjoy how immersive technologies and new modalities for manipulating and understanding data are shaping innovations in science, in engineering, and art. These immersed events will be a mixture of lectures and demonstrations and tutorials. We hope to offer a deep dive into the capabilities and set of capabilities that are available at MIT, that are available because of the innovations in AR and VR, and the innovations in GPU technology, and the innovations in thinking of how to intersect design, art, and engineering and science, to explore biology, human health, in diverse fields of engineering and science. Immersed is sponsored by the MIT.nano Immersion Lab. We provide tools, spaces, people, resources to connect the physical to the digital and bring together researchers in these diverse domains. So Immersed builds on this foundation that immersive technology and new modalities for manipulating and understanding data are shaping all of these interesting innovations across science, engineering, and art. This first session today, we would like to be coming to you from the Immersion Lab. So we are virtually. A quick tour of the Immersion Lab. The Immersion Lab sits inside of MIT.nano, and my background is the MIT.nano facility. Like all of MIT.nano, the Immersion Lab is open to the MIT community and to outside users. It is a heavily instrumented, reconfigurable, two-story space, a black box theater, plus compute that allows us to use the human as a specimen in the instrument that is the Immersion Lab. The Immersion Lab will facilitate. Immersed means being able to look at new ways of teaching and learning, using a language of gaming and teaching and learning, open spaces for classes and presentations, hosting classes in virtual reality, offering both educational and learning opportunities through both internships and undergraduate research projects. Through COVID, through this unique world that we've been living in, we've also made the resources that are available inside of the room available to the rooms of our students, into the rooms of our researchers, looking at both developing novel ways of exploring molecules that are only visualizable at the nanoscale, or learning how to interact and measure physiological response as people are immersed in virtual environments. And what does that mean in terms of designing new games and new ways of interacting and new ways of learning? One of the tools, one of the many sets of types of tools that are celebrated by Immersed that are available in the Immersion Lab are a collection of tools for photogrammetry. In this case, an instrument that has over 120 cameras that are on reconfigurable stands that allow us to capture humans, that allow us to capture physical artifact, both a three-dimensional representation that can be then animated and articulated, the geometry, but also the skinning, the coloring, the texture. So it gives us the ability to take a physical artifact and get it into the digital world. Photogrammetry at the space scale. So cameras such as this Matterport camera that you may be familiar with if you've ever either rented or purchased an apartment online in the modern era, where you can take a camera now, very similar to what Google Maps does, or Google Street View, when you take a camera out into the world, take cameras into the spaces and capture, in this case, the infinite corridor, so that you can virtually interact with these physical spaces. So photogrammetry is one set of tools that we celebrate and use. Motion capture. We'll hear a lot today about motion capture in dance and biomechanics, but the space, this reconfigurable space that is the Immersion Lab, instrumented with cameras that allow us to track markers and understand how people and artifacts are moving around. The Immersion Lab is an integrated instrument for humans, bringing together sensors of optical sorts, of radar sorts, 360 cameras, motion capture, wireless physiological monitoring that really allows us to put the specimen of the human into the space, understand how they move and interact and their signals of response. On top of all of these things, we have an infrastructure for compute, for data visualization, for acquisition, interaction, and interpretation of the data that we're acquiring. The tools and capabilities of the Immersion Lab that are celebrated by this immersed series, graphical form and available on our webpage, everything from immersive teaching, exploring and interacting with complex data sets, whether it be through AR and VR, wall-mounted displays, creating immersive content, digital twins, digital models of both human and physical artifact, motion capture, machine learning, physiological studies, art and music, melding the physical and the digital. In text form, if I were to summarize the tools and capabilities of the Immersion Lab, tools that are available to you. If you're listening to this, if you're watching this, these are available to you. Virtual reality, motion capture, media content creation, photogrammetry, and computation. Our mission is to help you do the phenomenal things that you want to do, to propel research and education, to bring together these array of different technologies in creative ways in a single environment, facilitate teaching, facilitate interdisciplinary cross-pollination between art, science, and technology, and bridging the domains of hardware innovation and software innovation, and fueling the experimentation and research that you want to do, both through the resources and the opportunities that we have for funding. The Immersion Lab, immersed, means being immersed in things, immersed in data. So whether your interest is being immersed in sport and motion, or being immersed in sound, or being immersed in data, I want to welcome you to the Immersed series. Here we go, getting our oranges immersed in water. So immersed, a monthly celebration of all the technologies that we're the users of the technologies that we're celebrating today. So I want to just sort of give you that as a little bit of a background and overview of the Immersion Lab, which is hosting this event and series of events. And with that, I'll turn it over to my colleagues, Praneeth, Samantha, and Ben, who will be sharing little vignettes about some of the first uses of what we've done in the Immersion Lab, and I look forward to your participation and questions. So Praneeth, take it away.
Thank you, Brian. One of the latest things to come out of the Immersion Lab are two educational courses that we ran over independent activities period this past January. Today, we're going to talk about these two courses. I'm going to talk about biomechanics in everyday life. This is the course that I led. And later, Sam Farrell is going to talk about creating, editing, and distributing 360 photography. So let me tell you a little bit about the course and give you a taste of what the students experienced. So in this course, students learned how motion capture photogrammetry and EMG can be applied to understand more deeply everyday activities like breathing and walking. First, I'll tell you what students liked about the course, and then I'll try to give you a taste of it. So from our feedback, so this course ran over 5 sessions. And according to the students, they were able to participate in the course through this interactive app, which I'll introduce you to in just a second. And they learned to challenge their intuitions. And we'll learn to challenge one of our intuitions today. And then they enjoyed live demonstrations and a combination of experience-based and presentation-based learning. What I mean by experience-based and presentation-based learning is, for example, we had a yoga teacher come over and lead a 20-minute yoga session. After that, the students got to hear about analysis performed using the tools in the Immersion Lab. I'll show an example of that in a second. But if you have a secondary device, such as a phone or an iPad, please open a browser window and go to slido.com. And go to event number C442. Now, when you join, you can upvote this. You can all ask questions, upvote questions people have asked. So I'll know once you have joined. So once again, it's slido.com. Excellent. We have our first participant. Give just a minute for people to join. slido.com, event number C442. I wish I could provide coffee virtually. We'll get to the Q&A session in the end, so thank you for starting to ask your questions. Excellent. So we have some participants. Thank you for volunteering. Now, here's a sneak peek of what, okay, so let me explain. When you if you're in your living room, just stand up and try to jump around. As you jump, your muscles are going to change the length. So for example, if you move your bicep, it's going to get longer or shorter and so on. So on average, when are muscles longest during jumping? What does your intuition say? Is it at the highest point of jump when I'm in the air? Is it at the lowest point of jump? Is it just when I'm about to take off? Is it the moment I'm going to take off from the floor, or just when I landed on the floor? What do you think? When do you think, if you take the length of all the muscles and average them, when do you think they're going to be the longest? I'll give you a second to answer. Okay, let's see what you're saying. The moment before taking off from the floor. Excellent. Let's see what students said. In the course, the students, most of the students said it as the highest point of the jump. But the correct answer turns out to be this. Somebody got it. They're very happy. Good job. Okay. So this is part of testing whether your intuitions are correct or not, but then how do you tune your intuitions? One thing we can do is take a closer look using motion capture. You can measure the length of muscles as I'm jumping rope. This doesn't tell you very much. I'll show you, tell you much about muscle length, but gives you an idea of how the experiment was conducted, how the observation was made. Okay, here is the length. So let me explain. There's a graph here. So I'm jumping up and down. The blue line indicates the position of my toe. So when the blue line goes up, it means my toe is in the air. And this is the moment that I landed on the floor. This is the moment I'm taking off from the floor, right? So lowest point of the jump is probably somewhere close to that. So what happens here is once I touch the floor, my muscles start getting longer. So in this case, it is my arm muscles. So these specific muscles on the left, right? So you can repeat this for many different muscle groups, and you'll find something very similar. The question is, how can we retune our intuitions? So in this case, we did it using a toy model. If you can see my live video, so here's a toy that many children use to play with. So it has a bunch of rubber bands and some wooden sticks. And then it is pliable, much like our bones and muscles. And there are important differences. So I put infrared reflective markers on the corners so I can track the length of these elastic bands. So this is what happens when I drop it on the floor. It was too fast to see. I'm going to slow it down. So it's getting to the floor. Once it touches the floor, it's going to get squished. Even though it's getting squished, the length of the elastic bands increase because the body is absorbing the energy. And then, so that's the lowest point of your jump. And then you retrieve that, and then by the time you take off from the floor, your muscles are actually the shortest, right? So here's an example of testing your intuitions and refining them. And students learn to apply this to everyday activities, right? So perhaps observing things that are not very obvious to see unless you have a lot of experience and intuition. So here is me tracking my lat during yoga. And then I'm going to stay in one pose and I'm just going to breathe. So as I breathe, you see that my back is responding. Maybe it's not obvious from the video, but it's just a centimeter of change, right? So then you can take a closer look from a different angle, and you can see that during the inhale, I tend to expand even in my back. So I'm expanding overall. So students use this to deepen their intuitions about how breathing relates to yoga. I am running out of time, so I won't. I'll show you one more video. So students also learned how to develop their awareness using Tai Chi. And we used biofeedback demonstrations. So what I'm recording are from the sensors that are on my arms over here. And they show acceleration, or when in this case, I'm looking for when my muscles end up tremoring. Maybe you spotted it, maybe you didn't, but it happened right there. And you can see the tremor very clearly, right? So my shoulder gets a little unstable when my hand goes into this position, and when my arm goes into that position. So I happened to document where I had the sensors. I had my shoulder in the same position, and I saw the same pattern. So students learn to, in this course, students learn to develop an appreciation for deepening their intuitions and awareness and understanding, and how these tools can help in that regard. If you're interested in the course itself, then the video recordings are available online, and just send us an email to immersion@mit.edu, and I can send you a link to the videos. Now, I'm going to turn it over to Sam.
Hi, everyone. My name is Samantha Farrell, and I am the assistant to the director of MIT.nano, Vladimir Bilovich, and I'm also a VR, AR, science, sci-fi enthusiast. So in my case, working at MIT.nano generally, but specifically in the Immersion Lab, is quite a thrilling and exciting place to be. And I'm thrilled that I have a chance to have a little impact in trying to help with getting some of the programming going. I'm going to give a little overview about a very exciting and successful class that we hosted over the IAP period that was called Creating, Editing, and Distributing 360 Photography and Videography. So I got involved in the Immersion Lab when we were starting to have conversations about our potential users. How do we make this a welcoming space? How do we build a diverse and interdisciplinary community of users? And if I have learned anything during my time at MIT, I know that the magic of MIT really happens when you get folks from all disciplines across campus bumping into each other, bouncing ideas off of one another. And as Vladimir has coined the term to me, it's that human friction that sort of leads to this incredible innovation and imagination that MIT is known for. And I think that the Immersion Lab has the potential to be such a place of intersection where storytelling meets big data, meets art and performance, meets technology and ways of communicating and research. So it's just a really exciting a space that I hope that we're just going to see keep growing and growing and evolving. So I took myself as an example of a person who would like to use the room, but perhaps is not a scientist. I'm not a scientist. I'm an administrative assistant, but I'm also a musician. But I know that research starts with people asking questions. How does this work? How is this molecule put together? What is this, how do things operate on the nanoscale? So my question was, how do I make a weird music video in 360? That was my jumping off point, because I'm interested in immersive experiences and sound. So yeah, so if you're not a computer programmer, if you're not doing biomechanical research, if you don't know how to use the Lens Cloud, I don't know how to use any of those things, but I'm like, this is really an awesome room, and I love the idea of VR and AR. How do I get involved here? So then, let me just go here. We enter Russ Gant. He is the director of the Harvard Visualization Lab, and he's a leading expert on virtual reality technology, and just an amazing all-around artist and entrepreneur. And I had the good fortune of getting to go get a tour of the lab space at Harvard with Vladimir, and Russ made the mistake of giving me his cell phone number and his email, and I started pestering him with questions. How do you do this? Where do I find that? How do you create something? How do you create content for 360? And if you're trying to figure this out online by yourself, it's kind of overwhelming and there's a lot of, it's hard. It's just a difficult thing to try to figure out yourself. So out of a lot of those conversations, he was like, we should probably think about creating a workshop on how to create content for 360 environments and immersive environments. And I was like, yes, please sign me up right away. So over the month of December, basically, we were talking about what this would look like. And the goals of the workshop were to introduce the art and technology behind 360 photography and videography. And there is actually a long, rich, and varied history about humans working and wanting to be in immersive experiences, and which I'll show an example that Russ gave some really fantastic and engaging lectures on. Learn how to integrate photographic and graphically produced content into finished VR applications. So basically, if you make something, what do you do with it? Where do you put it? How do you work with the Oculus Quest? How do you get it on the Quest store? How do you sideload? How do you work with YouTube 360? Like, what are the options? There's a lot out there. So this was like a really nice guided tour. Introducing the students to the specialized cameras and the editing software packages. A lot of the people who took this workshop, they had never held a 360 camera before. They'd never used Adobe Premiere. And by the end of the week, the first week, everyone was actually already making videos and little short films and all sorts of stuff. And the software packages are difficult. There's a high learning curve when you're trying to learn how to use Adobe Premiere, but also learning how to use it for 360. So we had instructors who were walking people through the entire process, how to add captions, how to work with the files. So it was really great. And then we just wanted you to gain confidence and start making stuff by like day one. We just wanted you to just jump in and start making things. And when we posted this, I wasn't sure how many people would sign up, but I knew MIT folks, they love making things. Just give them tools and let them run wild. So we had a really great turnout. We had 70 people who signed up or expressed interest. But because I was buying Oculus Quest headsets during Christmas, I could only purchase so many. So we could only accommodate 10 students and 5 staff members per the class. But we had people from almost every department on campus. We had undergrads, we have graduate students in architecture, in the humanities, in CAST. We had staff members from communications departments on campus, from the Government of Community Outreach. We had research scientists at MIT.nano who were really interested in doing lab tours. So if anything, we will definitely be offering this again. For sure, hopefully in person, we'll see how that goes, but clearly there is demand and desire for people to start making 360 content and working with those applications. So the way this worked, oops, let me go back, is that we sent everybody a kit, or we delivered one locally that included an Oculus Quest headset, the Ricoh Theta 5, which is just a really nice base model of a 360 camera, and a monopod. You don't want to use a tripod, because if you do, then when you look down in your 360 video, all you're going to see is tripod legs. So a monopod is a really important tool to get started. Oops, okay, sorry. And then our instructors, Russ assembled a crack team from Harvard to come teach us everything we needed to know. That included Kachina Studer, who is the whiz on Adobe Premiere and working with files and file management, and sort of how do you make your computer not blow up and start smoking when you're working with these gigantic files. So she helped everyone walk through the entire process from start to finish. Josh is just, he's the lead engineer over at the Harvard Viz Lab, but he also has just been in the space for so long, and he was the tech sort of go-to, I can't get this to work. And then we had a guest speaker, Jenny Gao, who's amazing. She is a professional. She's like one of the world's leading professional 360 videographers and producers. And so she came and gave us a professional perspective on how she got started, tips and tricks on how, for workflow, and how her perspectives on shooting and different techniques that you can use to create really compelling videos. These are some of the examples, I thought it'd be fun to show that on day one, Russ was starting with the 39,000-year history of alternate reality. I bet you didn't know this began in the caves, but it did. And then by the end of the week, we were at a history of the future. So if your mind wasn't bent by the end of Monday, it was definitely bent by the end of Friday. It was really fantastic. Let's see. So sorry, let me go back. So the format of the class, we offered two-week sessions. We met on Monday, Wednesday, Friday for like 4 hours each time. And it was a combination of background lectures, like the ones that I just showed, giving context about like where we are in history with the development of these technologies, and then virtual hands-on workshops about how to create content from beginning, middle to the end. So we had office hours. If you were on Tuesday shooting something and you couldn't make anything work, you would just sign in and talk to our instructors and they'd give you one-on-one instruction. We just encouraged everyone to not be precious, just jump into the deep end of the pool here and just start making things, because that's how you learn. And then Harvard also curated 70 videos in a playlist for us to show the good, the bad, and the ugly, because if you don't shoot correctly, or you're not careful with how you're shooting, you're going to make your audience very seasick, and they're going to want to throw their headset at you and never use it again. So we had to learn by watching and imbibing a ton of material. And then we kept going with the one-on-one sessions. And then we had, at the end of the week, after people had had some time to start making some things, breakout sessions with the instructors, where we would all show our work and get commentary, critique, advice, sort of like conceptually thinking about how we could improve what we were working on. It was really great. And let's see, so here's just an example of some of our breakout rooms. We had some really lively discussions where people really felt that they learned a lot from that sort of show your work moment. So the types of projects that we worked on, all sorts of stuff. And this is just a taste. That we have some people who are doing virtual tours of MIT Nano, including one from a perspective inside of a tool, which you don't get to see that very often. I'll put some links in the chat after to some videos so you can check these out. So lab spaces and tours are always really popular, especially in the time of COVID when we can't go anywhere. People were making narrative short films that were hilarious and very inventive and just very unique. There's work, people are working on creating an immersive cooking class to be in partnership with the Kitchen Matters series from DMSC, where grad students do a recipe and then explain sort of the molecular gastronomy and the physics behind what they're making. There are science writers who are trying to get more engaging content for MIT news. And then there's people who are working on taking objects from videos, turning them into 360 objects, and then using gaming software and animation software to virtualize those. There's undergrads who are doing just immersive, like what's it like in the day of an MIT grad, weird music videos still in process, and much, much, much more. So what's next? We're definitely going to do more of these. Clearly, people are excited and want more of this, and I want to continue to learn. One of the next steps is taking what you're working with in your camera and importing it into a gaming engine, and then you can start manipulating things in totally new, interesting kind of ways. Working with the Matterport camera, Russ at Harvard is actually virtualizing every inch of Harvard and to then import it into a gaming engine, and then just create sort of a completely stunning virtual Harvard. So there's a lot of people working on interesting things in that space. And then there's also spatial audio and recording for 360, which was something we wanted to do in this class, but we just kind of ran out of time because that's its own unique art form. But I'm excited to know, like, what do people want to learn? I'm still like learning a lot in this field. So I wanted to ask the question to anyone who's listening, what would you like to see? Are there certain workshops or resources that we could provide? I want to know. Absolutely. Facilitate meetings and conversations. I think that's a great point because there is actually a large number of VR and AR professionals in the area who are writing saying, oh, this is awesome. Like, I would love to be part of this and know more of this. And I think we have some really excellent convening power at MIT to help, make spaces for professionals to talk and experiment and have a chance to use these tools. Yeah, virtualization of physical objects. Yeah, I think that's, using the Lens cloud. That's something that I would really like to know. Yeah, absolutely. Okay. I'm conscious of time, so I'm just going to jump. There are recordings. I will post those. I don't have it up yet, but I will post these. Yep, data visual. Yep, all these are awesome. So, yeah, I just wanted to wait. So the last thing that we talked about in our class was that Russ was explaining how virtual production has been moving towards melding the digital with the real. And one example of this, where you can't even tell the difference, is the shooting of The Mandalorian is actually done not on Tatooine or in the deserts of Tunisia. It is actually shot on a soundstage that has a gigantic LED volume light stage. So all they do is like build out the foreground, and then the background is completely virtual, which kind of blew my mind. So that, of course, that brought us to Grogu. And that brings me to the end of this talk, which is how we ended our class, which is I hope we see you in person. And I look forward to seeing what kind of amazing things that we can create in the space. So thanks.
Thank you so much, Sam. That was amazing. Next up, we have Ben Moss. Ben is an excellent top of the class ballroom dancer, and he's one of the first users of the Immersion Lab. And we thought he could share some of his insights into using some of these tools for the first time as a user.
Thanks for the introduction, Praneeth. I'm a Course 6 alum, and my hobby over the past few years has been to be a ballroom dancer. And I've also helped to coach the MIT ballroom dance team. So that's really the capacity that I got invited to use the Immersion Lab and collaborate with Praneeth to take some physiological measurements to form some insights into dancing. And I'd like to share that with you today. But before we get into the topic of measurements or partner dancing, I wanted to show a quick video to prime your brain on how, as humans, we use every day our skill to perturb the center of mass of objects to result in movement. So the video I'm going to show to you here is from a company called Matter Design, which I think is also an MIT spinoff. And I don't have anything directly to do with them, but I thought it was an excellent example. So let's watch this video. And in the video, these people are interacting with these very heavy stones by just slightly perturbing their center of mass. And then because these stones are existing in the gravity field that we find ourselves living in, it results in movement. And some objects are very cleverly shaped to respond efficiently and usefully to a perturbation of its center of mass. But you could imagine also that if these objects were just rectangular blocks, that you could perturb the center of mass to move the object, but it wouldn't be as efficient or as useful necessarily. So if we look at the human skeleton, it's a bit less obvious, but the human skeleton also has a lot of very interesting shapes of the facets of the joints, so that perturbations of center of mass also result in efficient movement. Dancers intuitively understand how to perturb their centers of mass with skill and understand how the body reacts to those movements. But it's very difficult to, as a dancer in a normal situation, to have an objective reality about the center of mass, because it's something we have to infer from our proprioceptive system, and we can fool ourselves. So what's cool about the Immersion Lab, and what I really liked about it, is that it provides the tools to make a very accurate and direct measurement of the center of mass, so that we can check our assumptions about things like where the center of mass is. So one thing, for instance, is that the center of mass of the human body, if I curl myself up into a circle, can even be outside my own body if we average all of those segments. So it's often very surprising and sometimes counterintuitive where the center of mass is located. So one of the things we decided to measure is to take a simple example of a dance figure. And to give you the context of what I'm trying to measure, I'm going to show you this figure, which is called a tango closed promenade. And in partner dancing, perturbations of center of mass is a very critical communication skill. Perturbing the center of mass of either oneself or one's partner communicates an intention of where we're going, how fast we're going there, and other things like the timing and so forth. So it's part of the tactile language that gets used between two people in partner dancing. So let me show you this closed promenade so that you have an idea of what it looks like with a partner. So I'm dancing this with my wonderful teacher, Charlotta Jorgensen. So there you have an idea of what it looks like. So what we did is I went to the immersion lab and I put on the motion capture suit. And with the motion capture suit, I was able to put point markers on various bony landmarks or close to the bony landmarks on my body. We had about 24 of those landmarks. And then I danced exactly the same thing that I showed you in the previous video. And I have an intuition of myself of where I think I'm perturbing my center of mass. But I wanted to see if I could measure that using the Immersion Lab tools. So I'll show you the video of me performing the same action, but here in the Immersion Lab and wearing the motion capture suit. So that looks like so. So then the next step was to take the data from the motion capture system, which gives a point cloud series of points, and then extract from that data where my center of mass is. And in addition, I'm not going to show it, but we also did some calibrations in order to check that what we're actually coming up with as a center of mass is a reasonable approximation of where we think it should be. So here's what we see as a result of the motion capture. So this is the point cloud that gets generated from the system. And then what we end up having is, let's say, a series of X, Y, and Z coordinates for each one of these points, which correspond to bony landmarks on my body. Oops. Sorry. This video has been slowed down. So you can see right here that my center of mass goes a little bit off balance, and I'm doing that deliberately. And I'm trying to see if I can actually measure that perturbation as well. I'll show one more time. Yeah, so we did perform some synchronization. We took this into consideration, especially if we want to use different systems like the force-sensitive resistors, which in this case were on my feet, at the same time as using the motion capture system. So it is a little bit of a complication, and it's something to take into consideration, is how to synchronize these different systems so that you can correlate those series of data. But that is certainly possible, and it's something that I think most users of the Immersion Lab would likely do. So the next step in the process is that we found some literature which allows a mapping between the center of mass segments of a typical average adult male and what the approximate mass of that segment would be. So what we did is we took the different points and then we approximated a center of mass of each weight segment. And I ended up with 15 different weight segments for my body. So that's, for instance, head, thorax, abdomen, thigh, shank, foot, etc. And then I end up with essentially a bunch of different, a system of particles or a system of weight segments that then need to be averaged out to come up with a center of mass of me as a human. So it ended up being pretty straightforward to do that in MATLAB. see if I can move to the next slide here. And practically what happens is that we did this for each coordinate system independently, so that we have a coordinate that corresponds to the center of mass of my own body. And then what I was interested in doing is comparing the center of mass of my body to a representation of where my foot would be. So we used, for instance, the ankle marker for that one, which was located very close to the talus of my ankle. So then I can see when my center of mass, for instance, is ahead of both feet, in which case I would have perturbed myself off balance in a forward direction, or behind my feet, in which case I've perturbed my center of mass in a backwards direction. So now in this graph, what I'm showing you is I'm showing you the ankle markers relative to the computed center of mass of my own body. So for instance, if both ankle markers are negative, that would imply that I've perturbed my center of mass forward off balance. And if both ankle markers are positive, I have perturbed my center of mass backwards off balance. And if you see one ankle marker positive and one ankle marker negative, then my center of mass is somewhere in between my 2 feet or within my base of support. So this part I've highlighted right here in red is where, as a dancer, I have intentionally taken myself forward off balance in order to communicate an intention. And we also see that in the data. So I think we succeeded in showing what we were trying to show. So the next thing I was curious about, and Praneeth was curious about, is to what degree does casual walking have an overbalance? And do we use perturbations of our center of mass to communicate intent or to create intention within ourselves? So here I'm casually walking. I'm trying to do so without thinking about what I'm doing. And we were able to measure the same effect using walking. So there is a brief moment where by several millimeters, my center does precede both my legs. And it's not as pronounced as when I'm doing this intentionally to communicate a strong intention to another person, but it is apparent there, which is interesting. And I think that we can look at this to try to develop more intuition about how we perturb the center of mass in order to interact with ourselves or with other objects in our environment. So in summary, this is a demonstration of how we use the Immersion Lab's tools to measure center of mass perturbations. And previously, for myself at least, such understanding only came from my own proprioception and hopefully keen awareness of what I'm doing. But certainly that's subject to bias. And hopefully this style of taking data can deepen our understanding and intuition for the skills that we're using here. Thank you.
Hey, thank you so much, Ben. That was excellent. So today you heard a little bit about the tools and opportunities in the Immersion Lab and some of the things we have done and some of the ways in which the Immersion Lab can be used. The Immersed series is targeted towards creating and highlighting more of such uses and experiences, and also vaguely around the tools and capabilities of the Immersion Lab. So upcoming seminar series, we are going to do something similar in context of athletics. So Todd Carroll, a pitching coach from MIT, we are going to look at a baseball pitch. We're going to immerse ourselves in a baseball pitch. And the one after that, we are going to look at some wonderful fusion between art and photography and data processing with bullet time and light paint. We're going to hear from Eric Pare. He's a bullet time and light painting photographer. So you can always reach us at immersion@mit.edu. And now I'll open the floor for questions.
I just wanted to say thank you, Praneeth and Samantha and Ben for both the work that you've done in using the Immersion Lab and celebrating and also your words today. So very much appreciate it. We've been trying to ask or answer questions as we go. So there's a long sort of list of hopefully understandable answers in the chat. So feel free to either slide your questions or chat them, or as Praneeth said, send us a follow-up email. And we look forward to getting you into the space. We'll pause here for, again, additional questions.
Do we have any glass-free displays in the lab? I don't know what that means, but we do have a HoloLens, which is for augmented reality.
And all the sensor, all the reasons, this is, again, I think one of the questions that I saw was a couple questions about access, a couple questions about what's the difference between the Immersion Lab and other spaces. So the Immersion Lab, like all of MIT Nano, it's a shared and central facility. It's your lab. Right? There are costs associated with getting in there. We try to offset those and help you with those and be very creative and getting you to be users of the space so that we can tap into your creativity. We're here as a resource, in terms of both people and equipment and space. So it's our job to make our doors open to you. And if you have ideas both for equipment and functionality that we don't have, that you think is both of interest to you and a handful of your other collaborators on campus, do let us know. And we want to see you in the lab. We want to see you doing amazing things. So we want to provide the tools and the resources and people and expertise and software to be able to follow your passions. So looking forward to working with everybody.
And with regards to the question about number of students that can participate in a VR class, if you're talking about the number of headsets, we have different kinds of headsets. And if you don't care about what type it is or what brand it is, you can go up to 30 students.
And we also, for some of the equipment, like the headsets, you don't have to be in the lab in order to use it. We will facilitate being able to borrow and take the equipment to your space.
Brian, we have a question. Do you have programs for external researchers or artists, like residency programs or similar?
We don't currently have a residency program. That's a great idea, and so I think certainly something that we can consider. But there is, like all of MIT Nano, it's people both on campus and off campus can become users. So there's a process by which you become a user and to get trained for safety and understanding what it is that you're trying to do. But the short answer is yes. How we handle on-campus users and off-campus, a little bit different programmatically. Excuse me, but yeah, but we certainly are a resource for the broader community.
Brian, do you see the question in the chat? What is the best way to reach out and explore possible capabilities? Is there an opportunity to visit the lab? I think that's a good one.
So Praneeth, if you can go back a slide and just show the immersed email list or email, and then also if you hit the MIT Nano webpage, let me see if I can just real quick post the link
for the quick start form. Is that what you're looking?
Yeah, the quick start form.
You can go to nanousers.mit.edu. That's where we list all of our facilities. You'll find the Immersion Lab listed prominently in the menu there, and from there you'll find the quick the application form.
Thank you, Tom. So with that, I see we're close to, go ahead, Praneeth.
Sorry, I was just going to say, if you're in COVID times, if you're on MIT's campus with COVID Pass and have access to Building 12, we can give you an in-person tour.
So again, thank you everybody for your time and attention today, and Praneeth and Ben and Samantha for your great presentations and words. come back in about a month for April 28th, immersed in athletics, and then immersed in photogrammetry after that. And we also are very much looking forward to your ideas, either self-volunteer or suggest for other immersed experiences that we can share with you in the community. So with that, again, thank you everybody, and have a good remainder of your day.